Hello, welcome to the Mark Janard Show, the cybersecurity show. In this video, we're going to discuss ways to hack mobile apps. So without further ado, let's get right into it. We are going dark. However, before I proceed, please hit that subscribe button and the like button. Hit that subscribe button and the like button right now. Thank you very much. So we have reverse engineering, right? Decompiling and analyzing code. Tools like JAW, DX, and APK tool allow hackers to decompile Android APK files and examine the source code. This can reveal vulnerabilities or ways to modify the app's functionality, right? Modifying and repackaging. After decompiling, hackers can modify the app code and repackage it as a malicious version. Also, do not use this information illegally or unethically, right? This is for educational purposes, right? Now, there's also network attacks, right? Like the man-in-the-middle attacks, which is intercepting and manipulating network traffic between the app and server using tools like Burp Suite. Then there's exploiting insecure connections, which is taking advantage of unencrypted communications or improper SSL/TLS implementation. There's client-side vulnerabilities, right? That's insecure data storage, which is accessing sensitive data stored insecurely on the device. There's runtime manipulation using tools like FRIDA to patch and modify app behavior in real time. Now let's get into the realm of social engineering, right? There's the phishing attacks. That's popular, we all know that, which is tricking users into installing malicious apps or providing login credentials. There's malicious apps, which is distributing Trojanized versions of legitimate apps through third-party app stores. There's device-level exploits, right, which is rooting/jailbreaking, which is gaining elevated privileges on the device to bypass security controls. Exploiting OS vulnerabilities, that's a little bit more into the Apple sphere. Or let me not say Apple, let me not single people out, okay? This can be anybody. Which is taking advantage of unpatched security flaws in the mobile operating system. To protect against these attacks, developers should implement secure coding practices, use encryption, validate user input, and follow platform security guidelines. Users should only install apps from official stores, keep their devices updated, and be wary of phishing attempts, right? Now, here are some common here are some common vulnerabilities in mobile applications, right? Because I gotta say it again. I gotta say it again because for the people in the back, maybe I didn't hear me. There's insecure data storage. Many mobile apps fail to properly secure sensitive data stored on the device. This can allow attackers to access confidential information if they gain physical access to the device or exploit other vulnerabilities. There's insecure communication, right? Apps that don't properly encrypt data transmitted over networks are vulnerable to man-in-the-middle attacks and data interception. Why? Using deprecated protocols or poor SSL/TLS implementation that can expose sensitive information. There's weak authentication and authorization, right? Improper implementation of authentication mechanisms like weak password policies or lack of multi-factor authentication can allow unauthorized access to accounts and data, right? There's insufficient input/output validation. Failing to properly validate and sanitize user inputs and data from external sources can lead to injection attacks like SQL injection or cross-site scripting. That's XSS, right? XSS. There's improper platform usage, right? Not following platform-specific security best practices or misusing platform features can introduce vulnerabilities. For example, not using the iOS keychain properly for credential storage. There's insufficient cryptography. Using weak encryption algorithms or implementing cryptography incorrectly leaves sensitive data vulnerable to being compromised. There's client-side injection, right? That's where vulnerabilities that allow malicious code to be injected and executed on the client side, often through users' inputs. There's code tampering and reverse engineering. That's the lack of code obfuscation and other binary protections that can allow attackers to analyze and modify the app's code. There's overprivileged apps, right? Requesting excessive permissions beyond what's needed for core functionality increases the potential attack surface. So there's a whole bunch of nuggets here. And also the third-party component, right? Vulnerabilities, right? Using outdated or vulnerable third-party libraries and SDKs can introduce security flaws into the app. So you're going to want to implement secure coding practices and following the platform security guidelines. So that's what I have for you today. Please take a moment right now to hit that subscribe button and the like button. Again, if you like this video, if you appreciate the content, if you want more videos like this, please hit that subscribe button and the like button. Also, let me know your opinion in the comment section below. I appreciate your viewership. Stay safe. See you in the next video.